Hello everyone, so welcome back to this video. So in this video we are going to learn about 3DS algorithm. So DES stands for data encryption standard algorithm. So 3DS algorithm generally use DES algorithm 3 times so that it enhances the security of encrypted data. So while talking about DES is a triple layer security algorithm that I have already said that it use DES 3 times to enhance the security of data. So DES is also a block cipher. That means it operates as a block cipher, processing a chunk of fixed size blocks and encrypting each block independently for suitable for secure data transmission. The key length used by the DES algorithm is 116 bits. That is, each DES algorithm uses 56 bits. 56 into 3 equal to 116 bits, which makes it much more resistant to brute force attacks compared to the single DES algorithm. And talking about the backward compatibility, despite its enhanced security, 3DS maintains its compatibility with legacy systems and applications that use DES encryption. And DES is widely adopted across the various industries from finance, healthcare, and government, where data security is very important and compliance are crucial. So without too much delay, let's use DES in Java. So to use 3DS in Java, I have created a file under symmetric cryptography package with name 3ds example.java. So in this Java class, we will implement our 3DS algorithm and use it. So it will have a 8-step process. In step 1, we will define a secret key for our DES encryption. And in step 2, based on the secret key defined on step 1, we will actually generate a triple DES key. In step 3, we will create an instance of a cipher for 3DS algorithm so that we can initialize that cipher using the generated triple DS key for encryption mode. And in step 4, we will encrypt the plain text using the instance of a cipher and triple DS key. And in step 5, we will encode the generated cipher text by using base64 encoder so that the cipher text can be seen in a very readable way. And in step 6, we will again initialize the cipher in decryption mode, and then we decode the cipher text in step 7, and finally we will print the original message in step 8. So without too much delay, let's implement this one. So now let us define a key. The key size should be at least 24 characters for 3DS. And let us convert this key string in byte array, and it should be UTF, the character set should be UTF-32. So now let us implement step 2. In the step 2, we will generate triple DS based on this byte array. To generate a triple DS key, we will use DESCD key spec library or the class. So let us create a specification for 3DS using DESCD key spec class, and we will pass this byte array here. And then after that, we need to create a secret key factory so that the key factory will generate a key. To do that, use a secret key factory class, and we will get an instance of our algorithm, that is DESCD. So secret factory object has a generate secret method that will generate a triple DS key based on this specification. Secret key factory dot generate secret, and let pass specification. And let us save this in a secret key. So now let us implement step 3. In step 3, we will initialize the cipher for encryption. So let us use cipher class. Cipher is equal to, we can use cipher dot get instance, and the algorithm that we are using is DESCD in ECB mode with PKCS5 padding. So this is our instance of 3DS algorithm. And now let us initialize the cipher in encryption mode. Cipher dot init cipher dot encrypt mode, and we need to pass a secret key, that is secret key 1. So step 3 is completed. So now in step 4, let us use this cipher to encrypt our message. First of all, let us define our message using string, plain text. So we will use do final method here to encrypt our plain text, which is available in Cipher instance, which is here. So Cipher dot do final, and this will take an byte array of our message, plain text dot get bytes, which is given by get bytes method, and this will return cipher text in byte array format. So let us save in cipher text byte array. So now after this, we need to encode this cipher text byte array in a base 64 format so that we can have a nice readability. So to do that, let us create a variable string cipher text is equal to base 64 dot get encoder dot encode to string, and we will pass this cipher text byte array. Okay, so our cipher text is available here. So let us print our cipher text. Cipher text is, so now let us run our algorithm. As you can see here, the cipher text is this base 64 encoded byte array. So now in step 5, let us initialize our cipher instance again to decryption mode, which can be done by cipher text dot init method. Cipher dot init cipher in decryption mode, and let us pass our secret key 1, and this is the initialization process, and let us decode. So we have our cipher text here, we need to decode this. So first of all, we need to decode our cipher text into cipher text byte array. To do that, let's create a byte array called cipher bytes decoded is equal to given by base 64 dot get decoder, and then call a decode, and let's pass our string, that is cipher text. So we have a cipher text array in cipher bytes decoded, and let's pass this cipher text array to our do final method again. Cipher do final, and we need to pass cipher bytes decoded and a secret key, and this will return an array in byte format, that is plain text byte array original plain text. So we don't need to pass a secret key here because we have already initialized the secret key in line number 35. Okay, so this, and now let us print our decrypted data in step 5, which is given by sout original decoded and data is new string. We need to convert this array to a string. That's why we are using a string constructor and pass original plain text. So let's fix this typo and rerun our code once again. So as you can see, cipher text is this, and the original decoded data is hello world. So this is how you use 3DS algorithm in Java. So thank you very much.